Okay, so last time we went over one and two step equations. There's going to be three problems that I want to review before we get into the different types of things that come up in multi-step equations, which is anything that has more than two operations or more than two things to do. This is number 3 from the first PDF that was sent over. There's going to be some stuff that you're going to have to do first that doesn't necessarily follow the order of operations. But for you to be able to actually balance an equation, there's some stuff you're going to have to do the opposite of to get rid of it. For example, this one has x plus 7 divided by negative 1. There's absolutely nothing we can do until we get rid of divided by negative 1. So as long as you're recognizing you see division by negative 1, we're multiplying by negative 1. Now I'll give you x plus 7 equals 2. Now we're no longer dividing by negative 1. And then we see a one-step equation, minus 7 x equals negative 5. Negative 5 plus 7, you can see that I'm going to solve the problem simplifying the top. Like, is there any like terms? Yes. That's going to be your negative 5 and 7 up here. You can put negative 5 and 7 together. The reason we couldn't do like terms before is because x and 7 are not like terms. Distributive, no, we'll go over that. And do we see any addition or subtraction? So yes, that's what we would do first. Pretend that there's parentheses on the top part of division and the bottom part of division, but in order to do the top part, you need numbers, like terms, and then you got to get rid of that dividing. A lot of the same thing right here. In order for us to address the x minus 1, you have to multiply by 6. Since it's dividing by 6, and you can see it turn into a one-step equation. X minus 1 equals negative 42. So this is where you just rock and roll. X equals negative 41. And you can always substitute that answer back in. Negative 41 minus 1 is negative 42. Negative 42 divided by 6 is negative 7. This is where another little tricky thing comes in. Whenever you see a negative in front of a problem like this, that means you're distributing a negative 1 to everything inside. And we're going to go over distributive property. I just wanted to make sure, perhaps you were going to do it. I just noticed you made a mistake on this. So negative 1 times x is negative 1x. Negative 1 times negative 3 is positive 3 equals 8. So we didn't have any like terms, but we did have distributive. Do we have any adding or subtracting? See, look, now things are getting into a groove. So if you see a fraction, handle that denominator first by doing the opposite. If it's dividing by 5, multiply both sides by 5. If you see something outside of parentheses, that means you got to multiply everything inside the parentheses by that number on the outside. Then it'll get you where you're back to normal. Plus 3 is going to be minus 3. Negative x equals 5. This is another example of using multiplication and division, but also recognizing when you have a negative in front of something that doesn't have a number. This is where you would just drop in a little 1. And you can't have negative x. You're looking for what is x, because the original problem says what is x, not negative x. So what's happening here is you got x times negative 1. So you can divide by negative 1. Positive x equals negative 5. Okay. There's also another way to go about doing that. The way that it ends up being every time, but mathematically I just showed you the correct way. I just want you to understand if you see a negative x and you're taking its opposite, you have to take the opposite of both sides. That'll save you some time, but it's not showing the steps. The multiply and divide is what I just showed you earlier. So those are the three problems that came up on last week's stuff. You're doing a 1 and 2 step, and I went ahead and just threw some crazy stuff in there just to see. So thank you for making an attempt on that. Solve one variable equations with variables on both sides and an equal sign. So we're getting into multi-step now, and there's going to be some other steps you got to check first. I just want to review one-step equations and then two-step equations, make sure that we're on the same page. We always know that we're dividing the problem in half, and that's always going to be the equal sign that's creating that wall. We're identifying the operation. I see plus, so I'm going to do subtract. Minus 3, minus 3. 3 minus 3 is 0. Opposites always 0 out. 9 minus 3 is 6. So you can see I rewrote. Answer is 6. This is, you can start to see how there's just little differences in all of these problems. So there's not x or 1 plus x divided by 4. You can see there's a plus 1 here all by itself. It has nothing to do with the fraction. That's why we can start with addition, subtraction, dividing the problem in half by the equal sign, and saying, you know what, that says plus 1, or it's a positive 1. I'm going to get rid of it by doing its opposite. 1 minus 1, or plus and negative 1, whichever one you want to say, is nothing. So we're left with x divided by 4 equals 3. This is a simplistic version of what we were doing in those example problems from last week's work. You see that you can't do anything with this x until you get rid of this divided by 4. So we rewrote. Now we need to multiply and divide. What do you see? You see dividing by 4. So we're going to multiply by 4. X equals 12. So 12 divided by 4 is 3, plus 1 is 4. Check. The difference between distributive and like terms. Sometimes distributive will end up having like terms, and that's something you always need to check for. So distributive and like terms, these things are going to come up, especially when you have variables on both sides of an equation. You're going to be adding, subtracting, multiplying, and dividing like terms, so it pays to know what that stuff means. It's very, very simple. Distributive, on the other hand, you may find a little more tricky. I'm not sure, but let's go over it. So you can see here x plus 2 is being multiplied by 2. I want to go ahead and just write out a literal version to what that means. So here's what that means. X plus 2 twice. Okay? And we know that multiplication is a shortcut for addition. So you could say, hey, you got x plus 2 plus x plus 2. Or you could say, hey, you got x plus 2 times 2. Either way, I'm going to show you the addition way, and then I'm going to show you the multiplication way. So 2 plus 2, those are like terms. They don't have a variable after them, and both of them are numbers. So I can put those together. 4. It's a positive. And how many x's are right here? 1, 2. 2x plus 4. That's what this ends up being when you distribute this 2 into here. 2 times x plus 2. So 2 times x, 2x. 2 times positive 2. See how I put that there? I always associate the operation with the number. Unless that number says like plus negative 2, then it's like a definitive negative 2. 2 times 2 is positive 4. See, look, same answers. It's all the same thing. Okay. Next. 8 times 2x. Go ahead and give that a shot. And then 8 times negative 3. That'll give you 16x. And then 8 times negative 3 minus 24. And you can always write 2x minus 3 8 times, then add up everything that's a like term. 6 times 3, 18. Minus 2y. 6 times negative 2y. 6 times 2 is 12, so negative 12y. 9 times 2x, 18x. 9 times positive 3y, 27y. So you can see 2x plus 4, those are not like terms. This 2 has an x behind it. I can't put it together. If this 4 had an x behind it, I could put it together and get 6x. I can't do it. 16x minus 24. One of them has a variable, one of them doesn't. They are not like terms. 18 minus 12y 18 doesn't have a variable, 12 does. I can't put them together. 18x plus 27y. They both have variables, but they're different variables, so I can't put them together. Let's take a look at like terms. So you see how this one has an x? This one doesn't have an x? That means that that's as simple as that's going to get. You can't put those together. You see how this one has an x and this one has an x? You can put those x's together. I'll make a picture out of it just so it makes more sense as to why we can put that together. All right, you got 2x's and you got 3x's. When you put them all together, how many x's do you have? Yeah, you got 5x. That is putting together like terms. You can see why you would want to do that. It just makes the work more simple. You're dealing with less things. Okay. This has a letter after it. This has a letter after it. That means they're the same. They're like terms. That means basically you're just doing 2 minus 5. And that'll give you negative 3x. Okay, so these both have the same variable after them, but there's something different. This one has to the second power. That makes them unlike terms. If this were to have a little floaty baby too, then we could put those together and we'd get 16x squared. It doesn't, so these are not like terms. I mean, and I'm putting a check because that's as simple as it can get. You see that they both have a variable, but they're not the same variable. Here's another example of having 2 letters in a problem. These are like terms. They both have a number and the same letters following them. You'll even see in high school, it'll look like this. And you'll have to determine if those are like terms, and they are because y times x is still going to be the same as x times y. Anyway, this is as simple as that can get. So, like terms, distributive property, those things are a must. You have got to have those down. And just know that anytime you see a fraction with work on top, like number 3 on PDF 1 and number 3 and 4 on PDF 2, that you've got to get rid of that denominator before you start solving the problem. So let's go ahead and get into this with distributive like terms since we got the fraction part out of the way. So do you see distributive? Answer to that is yes. I'm going to work this one, and if you want to like pause the video and work ahead and then check, cool. If you want to work together on this one, I'm just going to keep going. So distributive. That means we have x plus 4 3 times. So 3 times x is 3x. 3 times positive 4 is positive 12. Now all we have is a 2-step equation. The reason that was multi-step was because we went from, we had to use other steps to get to the 2-step. Okay, so I'm going to make my dotted line wall here. So you can see that I didn't make the dotted line wall dividing the problem in 2 because there wasn't something I was doing to one side that I had to do to the other. I was simplifying something that could be simplified. So once I start trying to move things from one side to the other, that's when the opposite will kick in, and that's when what I do to one side has to be done to the other. So are there any like terms? 3x and 12? No, there are no like terms. Do you see any adding and subtracting? I see plus 12, so I'm going to do minus 12. 3x equals 8. Okay, I rewrote it. Do I see any multiply or divide? Yes, I see times 3, so I'm going to do divide by 3. 8 divided by 3 is 2 and 2/3. Okay. Go ahead, try this one. Go through the bullet points over on the left side. Hit those first. See what you got. Okay, So like terms, yes, we do have like terms. There's a number with a letter and a number with the same letter. Cool, I can put those together. So that's 7x equals 20. Is there distributive? No, there was no number outside of parentheses with a group inside, so that's not happening. Is there any addition or subtraction? No. Holy moly, this turned into a one-step equation. I rewrote it. Is there any multiply or divide? Yes, there is multiplying by 7, so I'm going to divide by 7. X equals 2 and 6/7. 7 goes into 22 times, and that's 14. So there'd be a remainder of 6, and you keep the denominator. Yes, these are turning out to be weird answers, but it doesn't matter. The process is what we're focusing on. Okay, take a moment. Try. Okay, I assume that you paused. I'm going to identify these are like terms. Yes, 6x and 2x. They both have the same variable after them with a number in front. Cool. Even if it was 6x minus x, that's still 1 in front of that x, so there's the invisible 1 again. 6x minus 2x is 4x plus 11 equals negative 5. I didn't divide the problem in half because I wasn't doing stuff to both sides. Distributive. Do you see any parentheses here with a number outside of a group? No. Addition, subtraction, yes. I see plus 11. So I'm going to do minus 11. Oh. 4x equals, all right, negative 5 and minus 11, giving negative 16. Rewrote. Multiply or divide. I see multiply by 4, so I'm going to divide by 4. X equals negative 4. So you're sitting there looking at this one going like, what? Hey, first, so these two are interchangeable. That's the hint I'm going to give you. These are the two things that would get done before you start balancing an equation. Okay? So I'm going to go ahead and give you a hint. Start with distributive. Take a moment, try and figure that out, and then we'll resume and see if you got close. Okay, so I'm going to rewrite everything I didn't underline, just like I would in an order of operations problem. 3 times 6 is 18. 3 times negative 2x is negative 6x. Okay, so do you see anything that could be like terms that you could put together? See some numbers and an x next to them. So I got a 3x and a negative 6x. 3x and negative 6x will give you negative 3x minus 18 equals 27. So I still haven't done anything to both sides of the problem yet. Now I'm going to start. There are no more like terms and there's no more distributing. I circled these with their signs so I knew what kind of numbers they were. Plus 18, plus 18. Okay, and then divide by negative 3. X equals negative 15. Okay. So there are two sets of distributive here, and then you're going to end up combining the like terms. Go ahead, give it a shot. 3 times x is 3x. 3 times negative 1 is negative 3. 2 times x is 2x. 2 times positive 3 is 6. Like terms. So we took care of all the distributive. Like terms, anything with an x behind it. So you got a positive 2x and a positive 3x. That'll give you 5x minus 3 plus 6 equals 13. So if you want to go ahead and just get rid of those things, all you're doing is writing down what's left after you added it. So 3x and the 2x made 5x. Then I rewrote after it, minus 3 and plus 6. Minus 3 plus 6. We still have more like terms. Minus 3, positive 6. What's negative 3 plus 6? It's positive 3. Now we're finally balancing an equation. There is one more video that's going to accompany multi-step equations. That's variables on both sides. I just wanted to make sure that we had these things out of the way. So going through our normal two-step, 5x equals 10, divide by 5, x equals 2. Okay, so now we're looking at more distributive. Go ahead, give it a try. So 2 times 3x is 6x. 2 times negative 1 is negative 2. Plus 2 times 4x is 8x. 2 times positive 5 is positive 10 equals 8. Like terms, 6x, positive 8x. Whenever you put 6 x's and 8 more x's together, you get 14 x's. I'm going to get rid of these. And then all you got to do is rewrite everything that's still there. Still have like terms. Negative 2 and positive 10. What happens when you have 2 negatives and 10 positives? Well, they end up canceling some of the negatives out, and you got 8 survivors of positive left. All right, now finally, we're solving. Add, subtract, yep, minus 8. 14x equals 0. Divide by 14. Nothing divided into 14 parts is still going to give you a solid 0. So what we're going to be looking at next time is something like this. And I'm going to show you this, and I'm going to include some stuff with what's being sent over for you to make attempts at it, and then I will make another video that clarifies the entire process. So the reason that the reason I wanted to go over like terms is because for you to do variables on both sides, you have to have like terms. So you can see how there's a number and a letter, a number and a letter, a number and a number, but they're on opposite sides. The advice that I typically give when solving an equation with variables on both sides is start with the side that has the lowest value of variable. Like, for example, which one's bigger, 3x or 2x? 2x. Yeah, hey, good job. So how are you going to get rid of 2x? You're going to subtract 2x. So we're left with 3 equals x minus 2. And you can see how that variables on both sides turns into a one-step equation. Then all we're doing is our normal stuff. X equals 5. So it's nothing intimidating. It's just there's just pieces, and those pieces have rules. So give it a shot and let me know what you have a problem with.